you need to know and explain the physical differences between the solid, liquid, and gas states in terms of molecular structure and particle motion. So the three states are solid, liquid, and gas. The molecular structure, a solid is tightly bound, it's organized. Basically, if it's tightly bound, the bonds between the particles are very strong. Liquid, we have strong bonds, but it's a random structure. Gas is where there are no bonds and the structure is random. The particle motion in a solid, the particles vibrate around a fixed point in some kind of structural lattice. In a liquid, there is vibrational, there's also translational movement that the particles are able to drift around. In a gas, we have random motion, vibrational and translational motion, and we have very high velocities. Now, we are faced with a way of looking at what happens when a liquid or a frozen substance is heated. So what happens when you continually heat a block of ice, which is at minus 20 degrees centigrade, until it has all evaporated? We have to think in terms of the energy that's inside the ice. The internal energy is a sum of the potential energies and the kinetic energies of the particles in the ice. As we apply thermal energy, we'll be raising the internal energy and will cause a rise in either the potential energy of the particles or the kinetic energy of the particles. So the internal energy is the total internal energy. This is the potential energy, which is basically locked in the bonds. When something is happening into the bonds, is it some kind of change in structure that way? That will be due to the change in potential energy. The kinetic energy, however, is basically a measurement of the average random kinetic energy, gives the temperature. So if the temperature is changing, that's basically a change in the kinetic energy. So here we have it. Imagine the block of ice, which is at minus 40 degrees. And we are applying thermal energy, so the temperature is going to rise. Why does the temperature rise? Is it kinetic energy or the potential energy that's changing? The temperature is a measurement of the kinetic energy, and the temperature is rising, so the average kinetic energy of the particles will be rising. So here we have kinetic energies. In the next stage, the kinetic energy is not changing because the temperature is not changing. So therefore there must be a change in the potential energies of the ice and the water. So in other words, the bonds are being broken, the energy that is going, an increase in the potential energy. So the bonds are effectively being broken, the particles are being pushed further apart. So that's a change in potential energy. Then when all that is melted, we have a change in kinetic energy as the temperature will start to increase again. Higher temperature means more kinetic energy. The potential will still be the same. And then in the last section here, the potential energy is starting to change as the more bonds are being broken, as it basically changed state from a liquid to a gas. And in the last section, it's just the change in kinetic energy. We have steam which is being heated. We need to describe and explain the process of phase changes in terms of molecular behavior, and also explain, in terms of molecular behavior, why temperature does not change during a phase change. So, a phase change is when there's a change of state. An example, changing ice to water, changing water to steam. Water to steam is evaporation, or solid to liquid, which is melting. And what happens here is some of the bonds are being broken. This is a changing potential energy. We know that the internal energy, which is increasing, is a sum of the kinetic energy plus potential energy. If the internal energy is rising, the potential energy is rising. The temperature will be the same, so the kinetic energy of the particles will be the same. So An increase in the internal energy will be an increase in the potential energy. The bonds are being stretched and broken. The temperature does not change. Why does the temperature not change? We are supplying thermal energy to the ice or to the water, but the temperature does not change. The energy is being absorbed in some other way. So the rise in internal energy is not going into kinetic energy, it's going into the potential energy instead. And it means that the temperature will be constant. The average kinetic energy of the particles will be constant. So, but therefore, the potential energy between the molecules increases as the particles become further apart and the bonds are broken.